Good morning, ladies and gentlemen. Welcome to completing the square and factorising by completing the square. Now, this video, I hope you've got coffee, because there's no easy way around this. You've just got to push through it, because there is some fairly brutal algebra, and if I make it through the video without an error, that'll be a small miracle. Alright, so let's say you've been asked to factorise the quadratic in front of us now. And you're like, well, a is 1, fantastic, it's a monic, so I'm going to go with my trusted and true sum and product. What multiplies to 11 and adds to 5. And you take your 11 over here, and you're like, well, things that multiply to 11 are neg1 and neg11, 1 and 11, and, well, nothing else. None of them add to 5. So straight away, we're stuck. How do we factorise this? Sum and product hasn't worked. Best solution from here is to go with completing the square. And completing the square works far, far more often. In fact, it works all the time, except with imaginary numbers, and we'll do imaginary numbers later, and then completing the square does truly work all the time. Why would you not just go for it if it works all the time? Like, why would you go with splitting the x rather than completing the square? Well, it's hard and a little bit miserable, and you'll see what I mean in a second. Alright, some things to recall before we do start is this factorization, or this expansion. A plus x plus a all squared gives us x squared plus 2ax plus a squared. So that's perfect squares. This, similarly, a perfect squares expansion. And the key here is setting up that 2ax in the middle. Similarly, note difference of perfect squares looks like this. So difference in perfect squares, when the second one is not necessarily a square, we can use this square root trick here. Now, these have been covered in previous videos, so hopefully none of them are particularly new to you. But basically, completing the square requires this, and that completes the square, and then this to factorize, 1 and 2. Alright, let's do this, completing the square. Firstly, ensure that the x squared coefficient is 1. It is. Good. And I'll show you what to do if it isn't. Halve the b term. So remember that this is b, this is c. Halve the b term. And I normally do this off to one side. So b on 2 is equal to 10 on 2 is equal to 5. Add b on 2 squared and take it off again. Now b on 2 squared is, well, 10 on 2 squared is 25. Now, why on earth have we done this? Add it on and take it off. Alright, let's look at that. X squared plus 10x, and we're going to add it on here, plus 25. Then back to ordinary, take 5, take 25. Why? You'll see in a second, but let's just convince ourselves that actually we haven't changed the equation. In fact, here there isn't even an equation. It's not like this is equals to something over here where we can add 25 to both sides. We don't have two sides of an equation to work with. We are stuck on just one side. And so what we can do is we can do things like this, add on 25 and take it off again, which doesn't fundamentally change it. It makes it a little more complicated, but if we simplify this, I'm sure you'll agree we get back up to there. So we haven't changed the equation. Alright, now, what has this done? What adding on that 25 has done has set up a triplet here. Now this triplet is special. It, by adding on that b on 2 squared, oh, come on, don't freeze on me, computer. Scroll up. Too far up. Apologies. OneNote's just dying a bit here. Keep this in mind. RA is 5. So imagine what we had down below is x squared plus 10x, x squared plus 10x plus 25. That A is 5. Scrolling down. God, OneNote is terrible. Why are we so slow? Apologies, this is hardly riveting viewing, is it? Alright. That A there is 5, And what that means is this portion I've highlighted in green can be factorised to x plus 5 all squared. And what's left is take 30. So that yellow combines here to form that. Now, take a second to convince yourself that this green is in fact that squared factor. Alright. And so far, we've completed the square. That is now in completed the square form. If we want to factorize it, we have to go one more step. The one more step is this. X plus 5 plus root 30. X plus 5 take root 30. That there is using the fact that this is really a squared take b squared in the form of, well, that whole thing is a and root 30 is b. Alright. Let's go another one. So, steps are, ensure leading coefficient is 1. It is. Take b off to one side, halve it, and square it. That is minus 8 on 2 squared equals 16. Because that's 4. Minus 4 squared is positive 16. Now we add that on and take it off. So that becomes x squared, take 8x, plus 16, always add it on, plus 13, then take it off again, 16 as well. Now this here is slightly different to above in form because we have a negative. That there's a negative. So, if we do this, x take 4 squared take 3. That's there. This is here. Note that this term here is always going to be b on 2. And if we see above, if I can go up, let me up. The b term, that there is b on 2. Alright, now it's not yet fully factorized. To fully factorize this, we would need to do x take 4 plus root 3, x take 4 take root 3. So note that at this stage here, it's completing the square. At this stage here, it's factorized by completing the square. Alright, here, and I'm sorry this is going for a long time, there's 2 more to go. If you want to take a break and get a coffee, go for it. Here, a is not 1. So what do we do when a is not 1? Well, we force a to be 1. We force a to be 1 by taking out that leading coefficient. So to remove the leading coefficient, we take out minus 2, leaves us with x squared plus 2x take 5. Not so bad. Now, we just leave that 2 all the way through. And I would like you to write it all the way through, because otherwise people forget it. So here, if we have 2x, well then b is 2. So b on 2 squared is just 1, because b on 2 is equal to 1. 1 squared is 1. Minus 2 square brackets, and you'll see why I'm doing them in a sec. X squared plus 2x plus 1 take 5 take 1 minus 2 x squared plus 1 take 6. The reason we've done the square brackets is because they're there to remind us that this minus 2, and this is a classic error that everyone makes, doesn't just impact that there, but this also. So, we'll need to look at that again right at the end. Both of those are impacted by the minus 2. But let's continue factorizing inside the square bracket. Minus 2 bracket x plus 1 plus root 6, x plus 1 take root 6. And now we can write the minus 2 out. X plus 1 plus root 6. X plus 1 take root. That's an interesting root, 6. Alright. One more to go. One more to go, and I'm sorry, I know this has been a long one. And this is what I mean. This will be one where you're like, oh, I'm never completing the square again. This can't be factorized using any other method except for completing the square. So how do we do it? Alright. Let's look at this. Oh, OneNote is freezing a little. Once again, a is not equal to 1. Here's the fun thing. Because a is not equal to 1, we've got to force 1 out. And I can hear what you're saying. We've got to force that minus 4 out. So we take minus 4 out. That leaves us with x squared. Oh dear. 4 doesn't go into the 11. We don't really have a choice at this point. It becomes plus 11 on 4x minus 6. Ow. Now, it's important we follow the process. So what is b on 2? Well, b on 2 is half of 11 on 4. Half of 11 on 4 is the same as 11 on 8. Convince yourself of that. So 11 on 8 squared is equal to, well, 121 on 64. Alright, now we treat that exactly the same as we had before. We add it on and take it off. We leave the minus 4 out there, deal with everything else in here. X squared plus 11 on 4x plus 121 on 64, take 6, take 121 on 64. Oh, beautiful. Minus 4, square bracket, curved x. Now note this here was what we added on, plus 11 on 8 squared. Then somehow we have to do 6 minus negative 6 minus 121 divided by 64. Yep. Is nothing pretty. Haven't factorized it yet. Minus 4, bracket, x plus 11 on 8 minus, or plus, doesn't actually matter, square root of 505 on 64, curl bracket, x plus 11 on 8 take square root of 505 on 64. Alright. Think I've got it right? Looks alright. Actually, it looks hideously ugly, and we need the square bracket on the end. But other than that, it's close to we're getting. Alright, I'm sorry that took so long. Completing the square, if you speak to the year 11s, doing methods is something they do again and again and again, and it's worth just getting down packed quickly. Alright, thank you very much.